In this video, we're going to go over the KutaSoftware Infinite Pre-Calculus free worksheet evaluating limits, and this is at jump discontinuities and kinks. Essentially, one-sided limits. So the difference between one-sided limits is that, for example, quickly looking at number 1 and 2, we're looking at the limit of the function as x approaches 3, but then after the 3, it has a positive, and that means as x approaches 3 from the positive side or from the right. And then looking at number 2, we have as x approaches 3 and then a negative afterwards. That means from the negative side or as it approaches 3 from the left. And those are very important, especially in these jumps and kinks. So let's go ahead and look at number 1. In number 1, we're evaluating the limit of f of x, where f of x is the piecewise function, negative x minus 3 for values where x is less than or equal to 3, and negative x squared plus 4x minus 3, where values of x are greater than 3. And we're evaluating that limit as x approaches 3, and there's a positive after that. So as x approaches 3 from the positive side or from the right. So coming from the right, we're going to be coming from this function, because this is the function that's coming from the positive side. And we're going until we reach 3 and the x, which is this circled value. So as x approaches 3 from the right, the function approaches 0 in the y, or f of x. So the limit of f of x as x approaches 3 from the right, or from the positive side, is 0. Now let's move on to number 2. In number 2, we have the limit of our function, 3 times the absolute value of negative x plus 3 over negative x plus 3, as x approaches 3 from the left. So that means coming from the negative direction, we're going to trace that function until we reach our value of positive 3 in the x, which approaches positive 3 in the y. So 3 is our solution in number 2. And you can see that if this was x approaches 3 from the positive direction, we would get a completely different answer. We would get a negative 3, because at x equals 3, there's a jump. So going from different sides, from the positive side or the negative side, we will reach different conclusions. Moving on to number 3, we have the limit of f of x as x approaches negative 2. And it does not tell us whether we're looking at this limit from the right or from the left, which means we have to take both into account. So coming from the left-hand side, or the negative direction, x is approaching negative 1. And coming from the right-hand side, or the positive direction, x is approaching negative 5. And because negative 1 does not equal negative 5, the limit as x approaches negative 2 does not exist. However, the one-sided limits do. So if we were to say as x approaches negative 2 from the left, that would be negative 1. And if we said the limit as x approaches negative 2 from the right, that would be negative 5. However, it asks for the limit as x approaches negative 2, and because we have two different answers that are not equivalent, the limit does not exist. Let's continue on to number 4. Now in number 4, again, we have the limit as x approaches 2, where this limit we need to look at approaching it from both sides. We need to look at from the positive side and from the negative side, because it does not specify. So let's locate x equals 2, which is this point here. Now for this function, as we're coming from the left or from the negative side, x approaches negative 3. And as we're coming from the right or from the positive side, x approaches -3 as well. So because -3 equals -3, that is indeed a value of -3 for the limit of f of x. Let's continue on to our second page. In our second page, we're going to evaluate each limit, and you may use the provided graph to sketch the function. So let's evaluate the limit at number 5. First, by sketching the function. Now, each of these are linear equations, which makes it easier to graph. So in number 5, we have f of x equals x plus 2 for values where x is less than or equal to -1. So from -infinity up and including -1, we're going to be utilizing the linear equation x plus 2. So our slope m is equal to 1 and our y-intercept b would be a positive 2. However, it's not going to cross that x-axis. So I'm not going to use the point 0, 2. However, I'm going to make a note of it to help me draw my line. So with a slope of 1, we can think of that as 1 over 1, or -1 over -1. And because we're looking at values where x is less than or equal to -1, we want to plot this to the left. So from our y-intercept of 0, 2, going down 1 in the rise and 1 to the left in the negative direction, we will be at the point -1, 1. So -1 is x, which is included in this interval, so that will be the end point of the first part of our function. Now, again, still using the slope, we're going to be going down 1 in the rise and 1 to the left in the run. And we can continue to use our slope to draw a few more points, or because this is a line, all we need are 2 points to make that line. So that's the first part of our function. However, we're to evaluate the limit as x approaches -1 from the left-hand side, which is the part of the function we've already drawn. Now let's graph the next part of our function, and this is for values where x is greater than -1. So we'll be starting at -1, however, that's going to be an open circle. So again, this is our linear equation that's in the form of y equals mx plus b. So our slope m is -1 over 2, and our y-intercept b is a -4. So graphing 0, -4, because that is indeed included in the domain. Now I'm going to use the rise over run, or our slope, to get to the next point. So down 1 in the y direction, and 2 over in the x direction to get to that next point. Now that I have 2 points, I can connect those to form our line. However, my endpoint of that line does not fall on that y-axis, because my domain is for values greater than -1, so I'm going to extend this line to -1 in the x. And remember, that value is going to be an open circle. So if you want to plug it in for a more accurate point, we'll plug -1 in for x. So we'll have -1 over 2 minus 4, which equals a positive 1/2 minus 4, which is -3.5, or -7/2. Now, looking at the graph, we're evaluating the limit as x approaches -1 from the left, or from the negative direction. So as we approach -1 from the left, f of x is going to equal a positive 1. So 1 is our solution in number 5. However, while we're at number 5, I want to show you another way that we could evaluate the limit. As opposed to drawing it out and seeing visually where the limit is on the graph, we can plug in the limit and solve. But because it's a one-sided limit, we need to figure out which piece of the function we're plugging that into. So if we're approaching -1 from the left or from the negative side, that means we're going to enter in -1 into the function that has a domain going from -infinity or going from the negative direction. And that would be this first piece, x plus 2, because the domain is x is less than or equal to negative 1. So that's all values of x from negative infinity to negative 1. And it just so happens to also include that value of negative 1. So that would be a square bracket at the end of that if we were writing the domain. So with that being said, we would take negative 1 and plug it in for x in that first piece, the piece in which our domain is coming from the negative direction, or from the negative side. So negative 1 plus 2, negative 1 plus 2, that indeed equals a positive 1. Now, let's move on to number 6. So for number 6, we're evaluating this limit as x approaches negative 2, and it doesn't tell us from the right or from the left. So let's see if there's a limit at all. Because remember, if we plug in negative 2 for the first piece and get a different answer than plugging negative 2 in for the second piece, that means the limits from the right and from the left, in other words, the limits from the positive direction and from the negative direction, are not the same, and therefore the overall limit does not exist. So let's plug in negative 2 into that first piece. So we'll have negative 2 squared plus 6 times negative 2 plus 8. Negative 2 squared is a positive 4, plus 6 times negative 2 is negative 12, plus 8, that is going to equal 0. So the limit as x approaches negative 2, this would be from the left, because we're coming from negative infinity in the x, so the limit as x approaches negative 2 from the left is 0. Now let's see what it is going from the right. And I'll just make a note, negative 2, this is from the negative direction, and negative 2, this is from the positive direction. So from the positive direction, we'll have negative 2 over 2 minus 1. Negative 2 over 2 is a negative 1, and the opposite of negative 1 is a positive 1. So we'll have 1 minus 1, which also equals 0. And because 0 equals 0, we know that the limit of our function as x approaches negative 2 is indeed 0. So we were able to find our limit without even graphing. But let's go ahead and graph for extra practice. So we know at the point negative 2 in the x, we're at 0 in the y. So I'll graph that at the start. Now I'm going to graph this quadratic that's going to continue from that point to the left. And in order to graph this, I'll do a t-table. So I'll have my x values and then my f of x values. So I already have negative 2, so let's do negative 3, negative 4, and negative 5. So plugging in negative 3, we'll have negative 3 squared plus 6 times negative 3 plus 8. That's going to equal positive 9 plus negative 18 plus 8, which equals a negative 1. So we have the point negative 3, negative 1. Now for negative 4, we'll have negative 4 squared plus 6 times negative 4 plus 8. Negative 4 squared is a positive 16, and I'm adding 6 times negative 4, which is negative 24, and then plus 8. 16 plus 8 is a positive 24, and when I'm adding that to negative 24, I'll get 0. So when I'm at negative 4 in the x, I'm at 0 in the y. And then I'll go ahead and evaluate at negative 5. Negative 5 squared plus 6 times negative 5 plus 8. That's going to be 25 plus negative 30 plus 8, which is a positive 3, because 25 plus negative 30 is negative 5, plus 8 is a positive 3. So then, negative 5, 3. Now I'll go ahead and draw this parabola. Now for the second piece, we have negative x over 2 minus 1. And this is in slope-intercept form, where our slope m is equal to negative 1 half, and our y-intercept b is a negative 1. So I'll plot our y-intercept, because that is indeed included in the domain, 0, negative 1. And because this is a linear equation, I can use my slope going down 1 in the rise and 2 over in the run, Or I didn't even need to plot the point to -2 because I could have used the point I've already plotted of -2, 0. So I'll go ahead and connect those points. And double checking with the graph, the limit of f of x as x approaches -2 is indeed 0. Let's continue on to our next section. In numbers 7 through 10, we're to evaluate each limit, and for this, we're not giving a graph. So how we're going to evaluate is by plugging in the limit for the correct piece of our function. And for this, it's important to look at the domain. So for number 7, we have the limit of f of x as x approaches 4 from the negative side or from the left. And the piece we're going to use will be this first piece, 2x minus 5, because our domain is for values where x is less than 4, so that's coming from the negative infinity direction of x. So from negative infinity to positive 4. So we're going to take that value of 4 and plug it in for x. So we'll have 2 times 4 minus 5, which is going to be 8 minus 5, which equals a positive 3. So 3 is our solution in number 7. Now if this was x approaching 4 from the right, from the positive direction, we would plug 4 in for this second equation, and that would have been -2 times 4, which was -8, plus 7, which would have given us a -1. So you can see that the limits are indeed different. So it's very important to note the x values for the different parts of the function so that you're plugging into the correct one. Let's look at number 8. Number 8, we're looking at the limit of f of x as x approaches positive 3 from the left. So again, we're going to be using this first part where x values are less than 3. We're going to be using -x squared plus 4x minus 3 as the equation for our function. So we're going to plug in 3 for the values of x. So -3 squared plus 4 times 3 minus 3. 3 squared is 9, so we'll have -9 plus 4 times 3 is 12 minus 3. -9 plus 12 is a positive 3, and then when we subtract 3, we'll get 0 as our solution. So 0 is the limit of f of x as x approaches 3 from the negative direction. In number 9, we're evaluating the limit of f of x as x approaches 1 from the right. So we're coming from the positive values, which is the second piece, where x is greater than or equal to 1. So that's all values of x that are 1 to positive infinity. So this is from the right, or from the positive direction. So plugging in 1 for x, we'll get 1 minus 4, which is a -3. So -3 is our evaluated limit in number 9. And then lastly in this section, for number 10, we're evaluating the limit at -3 from the negative direction. So from x values less than -3, we're going to be using this piece. So that's -3 squared, or the opposite of -3 squared, minus 4 times -3 minus 4. And that's because we're taking this limit of -3 and plugging it in for our x values in that first piece. So the opposite of -3 squared is a -9, and then we're subtracting 4 times -3, which is a -12, but as opposed to subtracting a negative, I'll write this as adding a positive 12, and then we're subtracting 4. -9 plus 12 is a positive 3, and when we subtract 4 from that, we'll get -1. So -1 is our solution in number 10. Now, onto our critical thinking question. It says, write a piecewise function where the limit of f of x as x approaches 2 from the left is a positive 1, the limit of f of x as x approaches 2 from the right is a positive 3, and f of 2 is equal to 2. So for this piecewise function, we're going to have 3 separate pieces. So f of x is going to equal, first off, we have a limit where x approaches 2 from the left. So that's from negative infinity to positive 2. So that's for values where x is less than 2. But when x is equal to 2, our function of x is 2. So we can write that middle piece in, f of x equals 2 when x is equal to 2. But now the limit from the right, or from the positive direction, so when x is greater than 2, so for values when x is greater than 2, if we're coming from the right, that limit is going to be different than coming from the left, so for values less than 2. Now the easiest way to do this is that we'll simply plug in 1 for our first part, f of 2 equals 2, we already have that taken care of, and then 3 for our last piece. That is one solution. It's as simple as that. F of x equals 1 for values where x is less than 2. So here we will have x equal to 2. So our graph will look something like this. Here are values of 1. Then at f of x equals 2, it's equivalent to 2, but for values where x is greater than 2, we're going to be at 3. So that is one piecewise function. Let's go ahead and try something a little more complicated. Now I'll quickly go over the example they gave us on the answer key. The limit of f of x is 1 as x approaches 2 from the left. So if we were to plug 2 in for x, so this x is really 2, we can do or perform some operation in order to get that equal to 1. So let's simply subtract 1. X minus 1 equals 1. Plugging in that value of 2, 2 minus 1 equals 1. So f of x, that first piece, is going to be x minus 1 for values where x is less than 2. Because remember, we were coming from that negative direction. At f of 2, when x equals 2, we want our function to also equal 2. So f of 2 is 2, so we'll plug in 2 for values where x equals 2. And then lastly, from the right, as x approaches 2, our limit is 3. So again, we'll have x, we'll perform some operation to get to 3. And we're going to use x as 2. So all we'll have to do is simply add 1. So now we'll have x plus 1 for values where x is greater than 2. And that is another solution for number 11. And we could have had many other operations or manipulations. For example, for this first part, in order to go from 2 to 1, we could have divided by 2. So we could have had x over 2 as the function for values where x is less than 2. Because x divided by 2 equals 1 as x approaches 2 from the left. Because x divided by 2 would be 2 divided by 2, which would equal 1. So you can see there are many different answers for number 11. So feel free to come up with a new function on your own and leave it in the comments below. And just remember, if you haven't already, please like, subscribe, and share. All likes and subscriptions are greatly appreciated, and sharing this video with your peers is encouraged as well.